Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A mixed aldol addition reaction is efficient, i.e., gives predominantly one product when one carbonyl component has no alpha hydrogens, so it can only act as the electrophilic acceptor, and the other component acts as the nucleophilic enolate donor. This avoids the formation of multiple self-aldol products. Step 1. Analyze option B PHCOCH, CH3, CH2O. Retrosynthetically, this beta-hydroxy ketone can be disconnected at the beta-carbon-alpha carbon bond, the C bond formed in the aldol. This gives the enolate of acetaldehyde, CH3CHO, acting as donor, adding to benzaldehyde, PHCHO, acting as acceptor. Benzaldehyde has no alpha hydrogens, so it cannot form a self-aldol. Acetaldehyde provides the enolate. The crossed aldol between benzaldehyde, no alpha-H, acceptor only, and acetaldehyde, donor, is efficient and well-known. The product would be PHCH or CH2CHO, the direct aldol adduct, which upon examination matches option B when viewed correctly as COCH, CH3, CH2O. Wait, let us re-examine. PHC is equal to O, CH, CH3, CH2O means a phenyl ketone. Retrosynthetic cut between the alpha carbon and the carbonyl carbon-bearing CH2O donor is equal to enolate of PHCOCH3, acetophenone. Alpha to C is equal to O, acceptor is equal to formaldehyde, HCHO, no alpha H. Acetophenone plus formaldehyde, no alpha H, PHCOCH, CH2O dash. Actually rereading structure, BPHC is equal to O, C, CHCH3, CH2O. The alpha carbon has both CH3 and CH2O substituents. Retrosynthetic disconnection, acceptor is equal to HCHO, formaldehyde, no alpha H, donor is equal to enolate of pH, CH2, CH3, propiophenone. Formaldehyde has no alpha hydrogens, so it acts solely as the electrophile. Propiophenone acts as the enolate donor. This mixed aldol is efficient because formaldehyde cannot self-condense via aldol, no alpha H. The product is the beta-hydroxy ketone PHCOCH, CH3, CH2O, which is exactly option B. Step 2. Eliminate other options. Option A PHC or CH3, CH2CHO. This would require two components both capable of self-aldol reactions, making the mixed reaction inefficient with multiple products. Option CPH CH2 CoCH CH3 C or CH3 2. The retrosynthetic precursors would both have alpha hydrogens, leading to a mixture of self-aldol and cross-aldol products, inefficient. Option DPH CH2 CH2 CHO. This is a 1,4-keto-aldehyde delta position, not a beta-hydroxy carbonyl compound at all. It is not a direct aldol addition product. Aldol gives beta-hydroxy carbonyls, not 1,4-decarbonyls without an O. Step 3. Conclusion. Option B is best prepared by an efficient mixed aldol addition because it uses formaldehyde, no alpha H, as the acceptor and propiophenone as the donor, giving a single crossed aldol product. Therefore, the correct answer is B. Therefore, the correct answer is option B.